started. Hope everyone is able to see my screen. Yes, I believe so. Yeah. Okay. So let's get started. Let's get started. So today we will see about how query optimization can be done effectively with MySQL 8. So yeah, let me get slow one by one. So this is about me. Yeah, I have around 11 years of experience, bit of old now, and worked with Yahoo before. And I used to actively participate in most of the conferences in inside India, and also actually write the blogs. Of course, it has reduced these days because of the work pressure. And I had the MyDBOps team, and I mostly hit the managed database service team here. Okay, yeah. So about MyDBOps, of course, we are into open source database services and consulting, and we take care of the top open source databases like MongoDB and Postgres, and we provide the consulting and the managed database as the services to most of the people in India and Middle East and US also. Okay, so without further wasting, let's get in. So this is our agenda for today, like why MySQL 8 and what are the new indexing features and how it can be improved. So we will see one by one slowly. Of course, in any time you can answer the question, you can ask questions throughout the course of this webinar and anytime. Yeah. So MySQL 8. So MySQL 8 is a major leap. That's what it is called by use the index look. Yeah, he has called it as a major leap from the SQL perspective, and also it's a major leap from the version perspective also. And it comes with a wonderful list of features. So MongoDB performance enhancement, already have spoken about it in some other session, and faster parallel replications like write sets and the fine tuning, and more security enhancements. So security has improved a lot and lot in MySQL 8 with terms of the encryptions and the user policies and stuff like that. And other operation improvements also, like you have now shell. You have MySQL shell, which do a wonderful job in the backup and recovery, and clone plugins and their integration itself. So those things makes things very easy. And SQL layer, at the SQL layer, now we are supporting CTE window function and lateral direct tables. Okay, yeah. So let's have a look at the indexing features which are available in 8.0, which can benefit. Of course, when it comes to indexing, right, MySQL uses B plus tree internally. B plus tree is and as we know, InnoDB is the prime engine. But when it comes to indexing, there is no specific feature as such in MySQL like what the other database has. But now we have a wonderful list of features with MySQL index. So the first and foremost is the functional index, descending index, and the invisible index. We will see about can be applied. So functional index, of course, MySQL do support functional index starting from MySQL 8013. So it's not part of the initial release like 8011. Yeah, it was released later. And the functional key parts, they can be indexed. Example, you have function like get off, or you want to club two columns and create index like sum of. They can be indexed. Mostly as a database administrator or database engineer, we might face queries like it will be masked by index. The column might have index, but it will be masked by the functions. When there is a function, it masks the index usage. And also JSON-based query, the JSON functions. So these JSON columns are obviously they are blobs, and they can be indexed using this feature like the JSON functions, and it can make things much better. So let's consider this query. So I have used the OpenStreetMaps as an example here. So I have used it is publicly available. So let's consider a query like that. You have to get a date for a particular day, that is, let's say, yeah, 15 days ago. Consider to 15 to 20 days ago. Exactly, it's 20 days ago. Now, what the problem is, the table has around 47 million rows. But though, even though it has an index, with this function, right, it masks the index usage, and the SQL goes for a full table scan. So obviously, this is not something which you need on your production. So what are the possible solutions? Of course, we can rewrite the queries, removing the functions, and give it to the application team. Hey, rewrite from your end. And we all know it might take time. It depends on the application teams and their priority. And if you want to take things in your control, of course, rewrite your plugin. This can help, but it comes with its own overhead. Uh, it has its own overheads. And then next option is ProxySQL. If you're using ProxySQL kind of solution in your application, obviously you have the control. You can write it via ProxySQL, but if you don't have, then again, you have a very limited chance. And also ProxySQL works only with the Linux environment. So you can't apply it if you are an enterprise user or in a Windows platform. This is not easy. And then there is a solution again that is there in the called virtual column, where you can create a virtual column with stored or on the fly generator, and then make it as a new column and then query from again. But still, it needs a rewrite too. So now with MySQL 8.0, you can create a functional index. Okay, so if it is a normal case, you won't use a date. Here you will use a date, and there is a extra braces at the end. That's it. So it means that you use the index, you have an index creator, and then it makes things better. See, from 47 million rows, the rows can just came to 423 with the function. It can be that I believe it will be only 423 rows available also. So the improvement is better. But is there any change? No, there is no change in the queries, or there is no additional override with the values. Okay, yeah. Let's go to the next one. So descending index. Wow. Yeah. Sorry. Yeah, I have changed it. Sorry, it's my mistake. Okay. So MySQL do support descending index from MySQL 8.0. And again, B tree. So B tree by default, it is a forward scan. If you look at the leaf nodes, your data is arranged in the leaf nodes and they're scanned in the forward, do the reverse order do work. But different sorting order, right? It can be benefited better. Example, if you have a order by class and you have ascending or descending, then your B tree makes sense, because by default B tree is sorted in the ascending order unless you mention it. So with 8.0, you have these keywords ascending or descending. You can use as a part of your indexing algorithm and can make your queries work really better. So yeah. Uh, and also the benefit is more. You can reap about 10 to 15% of the benefit by having its ordered index. Like the forward scans are much better when comparing to the backward index scan. So these queries are easy to identify because, yeah, see. So let's consider a normal case. Yeah, let's consider a normal case. Just a minute. Yeah, let me make it as a full screen. Sorry. Yeah. So yeah, let's consider a normal case. I have a columns, like we are ordering by the creation time and the display time with a limit of 10, and the ordering is descending order. Okay, both are we are ordering by the descending order. So obviously there is no index initially and it goes for a file sort. Yeah, you are sorting it, so it uses your sort buffer and goes for a file sort. But this is what we need in any production system. So let's just try creating the index. So we are creating index based on the order, the creation time, and the display name. Let's see how what happens. So now We use the index is used, but if you look at the extra, you see something like backward index scan. Well, if it is like prior version 5.7 or something, right, you won't see this. With 8.0, the optimizer has this descending index. So if the indexing is a backward scan, previously it would mention it is a forward scan or a backward scan. Now, if it is a backward scan, like you are in the you are reading in the descending order, then it mentions it's a backward scan. Then this is a hint. This is a hint. If you're not aware of it, you can just think of and use a forward scan or create this functional this descending order indexes to make the index a forward scan. So let us try it. Yeah. So yeah, this is the we uses the composite index and no ordering mentioned. The query uses the backward scan. By making it as forward scan, right, we can gain around 15% of the performance gains. It's approximate. It can differ based on your data, how much data you fetch, and other stuffs. So let us create the descending index. So the descending index is created. If you look, your extra becomes null. There is nothing like a backward scan or the backward scan. It means that you are going with the forward scan. You created the index in the reverse order. So I have both these indexes in this case, but still it uses only the indexes with the descending order. So I created with a just to for my naming convention, I use the keyword descending, nothing else, and it uses it perfectly, and the scan is much less, and we go for a forward scan now. Okay, yeah, you have a Q&A, yeah. So yeah, so Mahendra has asked the questions. Yeah, they are not available less than 8.0. Of course, they are not available. So in 8.0, the descending index, we have the keyword, but in 5.7, we have the keywords like ascending and descending, but they don't work as expected. So these index are available only from 8.0, and I don't think it will be ported back to 5.7. So the features are not ported back nowadays. So I don't think this feature will be ported back to 5.7. I believe it answered your questions, Mahendra. Okay, yeah. So yeah, it supports only InnoDB engine. As MySQL proceed further, right, they are focusing only on InnoDB engine. So the even if you have a support for even if you have a MySum engine, these things are not supported. And full text, of course, full text is part of the MySQL, but you can't use a full text with a descending order. It's not changed. And also change buffers, as we have the descending index, right? So they're not buffered in the change buffer. Change buffer is for all the secondary indexes. So change buffers ignores them in change buffering. So it means they have to go like the other keys, like the primary keys, if they are not buffered. So these are the limitations currently we have. Of course, they can be better. Yeah. Okay. And the second thing is the invisible index. Sorry, the final thing, third thing is the invisible index. So invisible index, of course, this is a feature that in other database engines like Oracle or MySQL might be, but I'm sure it's there in Oracle. So what is the regular indexing process? Like when a DB has the query, right? He finds the slow query, then he gets the query and he create the index, maybe in a dev, but you don't have the real-time data, but in one of the production slaves or prod, and then checks it. So once the index is created, right, the optimizer will start using it from the next session. Once the from the new IDs or query IDs, it will start picking up and using it or analyzing it, or you can say consider it for the index for the performance. Okay, and then we check the query performance. Is the index is used? Then if it is that, yeah, we try to retain the index, or else we drop it. So this has its uh, own negatives also. Example, dropping an index or adding index, right, can adverse effect on the application also, because the other queries might get affected, or even your own query will start picking up a different query, and you have to drop it in the production. and also recreating the index also takes a lot. So now we have what we have in 8.0. So we have a invisible index. So there is a keyword like visible and invisible. When you create the index, you have to use this. So what happens is by default, they are not visible to the optimizer, but you can turn on using the switch, use invisible indexes on. Of course, it is good to on at the session level. Of course, you don't want to affect the global productivity. Now you check the query. Now you can check it as a DB or a database and you check the performance. So if you feel that the optimizer is benefiting out of it, and then you can make it live. It's like a simple metadata change, so there won't be any locking, and you can drop it off if you don't need. None of your production queries or production traffic will be affected by these new index creations if you want to drop it. Okay, and the same you can apply the same for dropping the unused indexes also. Example, some cases we might have unused indexes or duplicate indexes. So we might not be sure the application might be legacy one. So in yeah, so there's okay. Let me answer the questions. So Mansoor Ahmad, the procedure is failing. Of course, yeah, not sure because we have to look at the complete procedure and give an answer. This is out be clear, of course, but MySQL 5.7 and it has a multiple changes also. Like you can use the MySQL upgrade checker and check it for the data level changes, but I'm not sure where this is failing. Might be the functions might be removed, I'm not sure. Sorry, I can't answer it without the complete procedure, Mansoor. And second, Anand Anudakar, invisible index is like session level only. uh, it's not like that, Anand. Like you create it for the whole table, but you make it visible for the optimizer. It can be globally or it can be at the session level. So I prefer a session level for to test it because the entire motto is to create the indexes which is not visible for the production traffic. Without affecting the production traffic, we have to create the indexes and make it live, make the indexes live when we feel we are comfortable. So this optimize switch we can try it at a session level as a DBA to check the performance before making it live. So that's all I mean. Yeah. So yeah, and now execution plan improvements. So MySQL 8 has a couple of improvements in the explain plan, that is explain plan and these tools. So let's see what they are. The first is the explain format entry. So and the second is the explain analyze. So explain format equal to tree. So already we have a couple of two formats. So one is the tabular format, or that is the traditional one, where we have the explain format in the table name. Of course, there are multiple things like explain extended, explain partition, stuff like that. Now they are all merged. The explain is equal to the explain extended. And then comes the JSON format, which speaks much more details from 5.6, which speaks much more details in Daniel, like the your scans, your cost, and everything. Now what is latest is the tree. So if you have a view at the normal other database like Postgres or Oracle, their explain format is in the tree. So that's a default format. So MySQL has introduced it in 8016. MySQL has introduced in 8016. So yeah, so that's where it gets started. So now it shows the query plans with the cost estimates and the row estimates. And you will have a proper indentation also to understand the flow, like what is done first and what is done second. The join order, you can say, or the union, if you have complex query, right? So it helps you to understand what is the first operation done, what is the second operation picked up, and what is the estimated cost. So this is a traditional or a tabular format. So here, let me explain the query. Here I have used unions over three unions. The table name is common, which is the node tag, and the queries are all similar without the different, but there can be a small difference in the where condition. I mean the values in the where condition, but they are similar. So it is a three unions. Okay, yeah, I am. So three different tables I'm joining over, and this is a what. So if you look, so the primary table is a node tag, that is the first table which goes there, and then the second is the weight tags and the relation tags, and finally there is a union among the all the three. So let's see how it is visualized in the tree format. So now this is the tree format. Okay, so what it does is like, so this is the highest level output, the union with material with deduplication, because we are using only union, not the union all. So that's why the duplication, yeah, is there. So union material, because we create a materialized view and view it at the end. So that's a top operation. But if you look, the node tag comes first, and then the weight tags, and then the relation tags. So these are three things, and each one have their own estimated cost and their conditions. So this will be much better, because now here it's a union, so they are in the same indentation. If it is a joint, right, the indentation will be the next level. The indentation goes to the next level. Okay. So explain analyze. So explain analyze the another important feature. It is released after this, like it's a two minor versions. So it's like you can say that it uses a tree only. Again, it uses a tree. And now what happens is this explain analyze gives the actual time spent in the each sessions. Like where is the time spent? The time is spent in the creating temporary table, or the time is spent in the join. So now you can visualize very clearly, and also it gives much other information, like when what is the time to fetch the first row, it means the scan, and what is the time to fetch all the rows, and what is the cost estimate, and what is the time spent on the each levels. So which is much better than optimizer trace. Optimizer trace is the feature we usually use to trace it, but this is much better and easy to understand also. Wow. Okay. So this is a explain analyze. So the same query, I have used the same query. So here it gives the actual time, that is the total time spent at the, that is the final output. And then the first table took around 182 milliseconds, and the second table took around 300 milliseconds, and the final table took around 18 milliseconds. So this is the actual time spent. So what it says is that totally the query has spent around 0.65 seconds. That's what it means. So I have a better, we will see the next slide for the better understanding. So yeah, so in explain, so this is the primary. It, when you have the tree, it shows the cost as like 83K for the first one, that is a primary table. But the analyst told this takes around 233 milliseconds, the primary table, and then the union one and the union two. So these are their respective costs and their total cost and the total timing. So we can see that it takes around 636 milliseconds. But yeah, when I tried the query comes around, the actual query comes around 55, that is 550 milliseconds. So there is a difference of between 100 to 115 milliseconds. So actually it is 5 to 15 to 30% slower than the actual query time. The actual query time and the analyze time can differ. So this is can be because of the internal operation takes time with evaluating everything. But this is a, but it gives a clear idea while comparing. So tree is the estimate, or you can guesstimate. So this is the close to the actual time spent. Okay, yeah. And the final thing is the optimizer improvements. So optimizer, so it's a very common word, like optimizer is the brain of any databases. So optimizer performs better with two things. One is the statistics, and the other is the algorithm implementations. So it can be like you can have a index, or you can have a in-memory table or whatever, but the optimizer should have the awareness about it. So generally optimizer speaks so much stats. Oh, there are stats like persistence stats and persistence stats and transient stats are there. So InnoDB has its own way of managing statistics in the of the tables and the indexes. So that's what it helps the optimizer to understand more about the data, like how much rows is there in the table, and how many and what are the columns, or these columns indexed, and what is their cardinality, and everything matters when it comes to query. So the two major improvements what I love to see is the, what I've seen is the histogram and the hash chart. So we will see about one by one. So let's first see about the histograms. Of course, data distribution is not uniform. We all know data is not uniform because your peak traffic is throughout the day. Your traffic differs from day to day in any application, right? Hours to hour, the traffic differ. The pattern is different. The number of sale made in a second half, which is the after 2 o'clock, is much higher than comparing to the first half of the day in any in any online e-commerce. So the stats differ. Okay, the data is not distributed uniformly, but according to the optimizer, if you, it means the data is distributed uniformly. That's what optimizer thinks. Example, if you have a 1,000 rows, it thinks that 1,000 rows are unique. Okay, that if you have a cardinality is 1,000 and you have 1 lakh records, it means what the optimizer thinks is okay, for any one record there is a 100 values. The selectivity is if it selects any one value, the probability is it's going to pick 100 values. So that's how the optimizer thinks, but that can't be the reality. Okay, so MySQL has the histogram from the version 8.0.803, that is before the GA, because MySQL is GA from 8.0.1.1, and it has only one more version again, that I think 8.0.4, and then they directly jumped. So histograms can be applied for your single column or multiple columns, and they can be applied based on the buckets. If you know the exact number of distinct values, then you can give the exact number, or if you want a eq10, then you can give the number of buckets. But this eq10 is really good for date ranges, and singleton is really good for the unique values. So let's consider example. So I have a table, and there is a column, let's say a date value, I will say the column, yeah, is data is public. So there are three values, 0, 1, and 2. Okay, and this is a distribution, the total count of records and the distribution. So this is a graph. So what here we mean is that we have a cardinality of only 3. We have a cardinality of 3 for the close to 4,000 rows. Okay, the cardinality is only 3. So let's see what happens without index. So without index, the optimizer thinks that okay, it is going to filter out 10% rows for every record, right? It's going to take out around 10%. That's what the optimizer thinks. I have given the 3 different values and there is no indexes on top of it. Now let us apply the histogram. Now the histogram is applied. See, with the 0, the filter goes really down because there is only 1, which is 0. And the other thing is the 1, which is a very high number. So it thinks that 97%. You are going to fetch around 97% of row. And the last one comes to 2.9. So it makes a huge difference when the optimizer estimating the rows. So estimating the rows and also pushing them in the join order. So these things make a huge difference. So and also histograms are really better than managing the indexes, right? Because indexes has to balance themselves whenever there is an insect. So example, in this case, this is a status column, and we don't think that you will be introducing a new status immediately, and that won't drastically differ. So the maintenance overview is really wireless, and it can be simply maintained by the analyze table. So analyze table to update the histograms can be updated. Okay, so the histograms can be updated or dropped easily with that. And the next thing, so there is a optimizer switch called condition fanout filter. So it is enabled by default, and this is the one which controls this optimizer or this optimizer algorithm. So here, the benefit is we are giving so much stats to the uh, optimizer so that it can make the selectivity better. Okay, yeah. So there is a table called column statistics. Of course, you can get the information from those table, what is histogram and what is the distribution. Again, it's showed as a JSON. You can use a JSON table and have a very beautiful output. Fine. And the second important thing is the hash join. So previously MySQL don't have a hash join, and they have to use the block nested loops whenever you are using a join over a non-index columns. Okay, yeah, sorry, yeah. So from MySQL 8.0.1.8, they introduced this hash joins for the non-indexed joins. Okay, so this makes what it does is it internally creates a temporary table in memory, and it uses the join buffer to be honest. It uses a join buffer and then makes a comparison with the hashes in memory for this join. So this makes things much better because hash joins are much better when comparing to your block nested loops. So the benefit is huge when you make the hashes, because it makes the eq references and the hashes. Initially they started supporting only the inner joins in 8018, and later it was adapted to from 8020. It started to we support left join and the right join. Of course, the left join is what we can write both ways. It can, and the right join is converted again to left join, and then they works. So BNL, previously it was the BNL, that is a block nested loop. Now it is completely removed out. The support for BNL is removed out, and it is only the hash join, and it is the only hash join that is there. So of course, yeah, as I told you, it's an in-memory hash table, and the default join buffers don't work really well here, because if you if a join buffer is really small, let's say consider if it defaults like 256K, and then it will overflow out of it, and it will create in disk. So that's where your performance get lost. So with the different row ranges, right, you might need a different join buffer size. But uh, what I have read in a blog from Austin is 16 MB is really a good size for a join buffer. And there was a optimizer switch called hash join to turn it on or off, but it was taken away. They don't work anymore from 8019. It was completely disabled. Even if you try to turn it off, right, you can't turn it off. But you can try to play around with the optimizer hints like BNL or whatever. Yeah. So beyond this, what are the other optimizations? Yeah, we come to almost the end, like common table expressions. So that really makes sense when you have a subquery, right? It can be making as a common table expression called again and again. And even with a simple subquery, the benefit is huge with the common table expression. And also derived tables is also released in MySQL, and the window function. This window function really helps in the your analytic query, like rank off, range off, and these kind of functions. And there are two more switches which I like to call out in the optimizer, which are released in MySQL 8.0. It is a prefer ordering indexing. So actually, it was a bug and it was fixed by this optimizer algorithm. Like when you have a order by over primary key, when you have different value in the var class and you have a order by over the primary key, so MySQL thinks that this order by with the indexing, right, which will have a better benefit and try to fix it. But what happens is it really tries to slow down. You might feel like the primary key, it is using the primary key and it is scanning only one row, but actually it goes for ordering and it can slow down stuffs. So this was now given a switch which was introduced I think in 8021. And now there is one more thing, that's a subquery to derived. So all your subquery will be connected to derived table for the better performance. So this is another switch which I like to call out. And there are others like hypergraph and everything, but they are just only for testing phase. They're not going to benefit us anymore. Okay. So with this, we almost come to the end of the session, and I'm open for questions. Yeah.
Thank you, Karthik, for an insightful and enlightening session. So we have a question from Pon Suresh Pandian. The system is a reserved keyword and it's added in 8.0.3. Rename this reserved keyword and try to restore. Will it work?
Actually, Suresh is trying to answer the previous one.
Okay.
Actually, yeah, which is for Mansoor. Yeah. So
Okay.
Marsoor, yeah, Marsoor recommend over this, yeah, because there are many reserved keywords which are introduced in MySQL with every versions. Example, if you look 5.7, virtual is a keyword. Okay, virtual is a keyword because they are reserved it because we have the virtual column there. And now we have this invisible and everything, so they become a keyword. And there are ways to overcome it, or we have to remove it or rewrite it. Of course, any more questions?
Thank you, Pon Suresh, for pitching in to answer for Masroor. We really appreciate it.
Okay.
Thank you, Karthik, once again. A session without questions is a session wasted. So here's our email address. to which you can write an email about the questions what you have. And we are excited to go live soon. So please follow us on our social media handle so that we will be keep on posting about the upcoming events and also the webinars which will be broadcasted live. Now that we have come to our end of our My Webinar 4th edition, it's been an honor to be among such accomplished individuals and to be able to present our perspectives before you all. Thank you all for being here today and taking the time to patiently listen to what we have to say. I wish you all a blessed day and a great year ahead. Take care, stay safe.
Thank you, everyone.